Okay, let's move on to the graphing part. Number 17, we have negative 6y plus 4x equals 12. Two methods you can do. One is using the intercept to find the x and y intercepts. So if you did that, find the x-intercept, we know y is 0. We plug in 0 for y and solve for x, and we end up with x equaling 3. Y-intercept, x equals 0. We put in 0 for x, solve for y. We end up with y equaling negative 2. And then we just plot those 2 points and connect the dots, and there's our graph. That's method 1. Method 2. We would end up going into the form y equals mx plus b. So then what we would do is subtract the 4x from both sides, and then we're going to divide everything by negative 6, and we end up with y equaling 2/3 x minus 2. Plot the y-intercept, go up 2 over 3, find the next point, connect the dots, you have the graph. Now y equals negative 3. We know that's going to go a horizontal line right through at y equals negative 3. Okay, here they gave us this one already in y equals mx plus b form. So all we have to do is find the y-intercept, apply the slope down 2, over to the right 3, plot our next point, and then connect the dots. Okay, so that's number 19. Number 20, let's just refresh ourselves over a couple things here. 1, remember we're looking at this form. The h represents moving things to the right or left, and remember to do the opposite of what you see. Okay, so make sure we do that. K moves the graph up and down. We don't do the opposite, we keep the sign. A, if it's positive, opens up, negative opens down. Also is a multiplier, multiplies those y values. Now remember, our standard parent graph is y equals the absolute value of x. So this is what it would normally look like without any changes. Now let's look at our problem and see what we have to do. Now in our particular problem, we know that we're going to move 2 units to the right. Okay, so as we move the 2 units to the right, vertex is at 2. There's no k, so there's no up and down, and there's no a value other than a positive 1, so we know it opens up, and everything stays the same. Over 1, up 1, over 2, up 2, over 3, up 3, and we know symmetry is going to remain the same. Now, if there is a multiplier, then we would change the upward movement. So if I went over 1, I would go up 1 times whatever the a value is. When I go over 2 units, I would do 2 times whatever that a value is. Okay, so make sure you have that down as well, and practice that on that sheet that I gave you in class the other day as well. Okay, this piecewise function number 21, remember the first thing you want to do is look at your key. Whatever number is there, if there's more than 1, we draw a vertical line everywhere we see a number. But we only see x equaling 1, so we're only going to draw 1 vertical line. Now, the top one says this only works to the left of 1. Okay, so we said y equaled negative x minus 2. And then we said the one at the bottom is to the right of 1, and that's always y equals 4. So we did that. Now what we want to do is we want to find where they're starting. So on the green one, we want to know where it's going to start when x equals 1. So what we do is we plug that into our equation y equals negative x minus 2. So we plug in the 1, so we get the opposite of 1, which is negative 1, minus 2, or negative 3. So our starting point is 1, negative 3. We look to see if it's an open or closed circle. We see there's no line under that inequality, so therefore we know it's an open circle. We apply our slope. Now, that might have gone a little too fast for you here, so just backing up. So if we were here at this point, we would say down 1 over 1, down 1 over 1. We don't want to do that. So we're going to reverse the process on that. So we're going to do the opposite, and we're going to plug in some points to the opposite of that, and then we're going to draw our graph and erase the other points. Okay? So that way we only have things to the left of 1. Now on the other side, we only have y equals 4. Well, y equals 4 is just that 1 point, and then it said it was solid because we got the line under it, and then we draw that line at y equals 4 solid all the way across, and that's done. Done with that graph. The next one's an inequality. So first things first, we got to find where this line is. So method 1 is find your x and y intercepts. So we know the x-intercept y is 0, so we found the x-intercept to be negative 2. Y-intercept x has to be 0. Calculate that. Y is 1. We look at our inequality. It says, oh, there's no line under it, so we want to use a dashed line. Now what we want to do is determine whether we're going to shade, which side we're going to shade on. So we pick a point, any point. I usually like to pick 0, 0 if I can. So I'm going to test the point 0, 0 and go with that. If I plug in 0 for x and 0 for y, I end up with 0 being greater than negative 2, which is a true statement. So therefore, I want to make sure I shade on that side where the point is. Now you could do the other method. You could say y equals mx plus b, resolve the whole equation for y. Don't forget, when you're dividing both sides by -2, you got to change that inequality symbol. So now you end up with y being less than a half x plus 1. It's going to produce the same graph. We can see the y-intercept there. We can see we go up 1 over 2. We're going to get the same graph. Make sure it's a dotted line. But again, you're going to test values. Again, you can plug in the 0, 0. So is 0 less than 1/2 of 0 plus 1? 0 is definitely less than 1. So yes, the answer. And we end up shading the exact same side. Okay, so that's the end of the graphing. Now it's off to the Desmos section.